Hey guys, David here and welcome to another video. Yes, I am making another video. I'm not completed yet. I'm yet again here with this CNC. It's been probably about 2 years or even more since I last worked on it, but I recently got back into it, and as you can see, it is very much taken apart. And I've actually done quite a bit already. The main goal is to, solve some of the underlying fundamental issues that I have with this machine. Spent a bunch of time building fancy controllers and whatnot, but all of that is kind of lipstick on a pig if the base machine doesn't work properly. And one of the main big issues that I've been having is way too much backlash. In the CNC world, backlash, everybody has it, nobody likes it, everybody has too much of it. But the levels of backlash I had on this machine were unacceptable, and basically meant that I was using my killer bee instead of this machine just because the killer bee was had less chatter in it and was being more precise, which doesn't really make sense since this is a proper milling machine and the other thing is a wood router. So what I did is I stripped everything down so I could actually access all of the ball screws and the ways, and had a good look at them and measured the backlash. In the y-axis I had around 0.1 millimeters, so about 100 micron. That's roughly 40 thou and miles in the machining world. And I think the z-axis is even worse. I've not done anything with that yet. The x-axis is a bit better, but still has a lot of backlash. So I have already worked on the y-axis. This one is actually a lot better now. I'll tell you what I did there, and then we'll move on and I'll show you on the x-axis doing the same stuff. But before we do that, I want to give a big thanks to PCBWay for sponsoring this video. Not only do they make really high quality PCBs, they also have manufacturing services, which, although I have a big CNC mill here, I'm working on it, it's completely taken apart. So if I need a part right now to fix something, I have a killer bee, but you might only have one CNC, so if you then need a CNC part, they are there for you. They have very reasonable prices and you can get quotes really quickly. And they also have various 3D printing services for all kinds of exotic materials. So if you need anything manufactured that you don't have the capability to do yourself, make sure to go check out PCBWay, link down below. Now, one of the first culprits I looked at was the whole ball screw assembly. I am using very cheap ball screws, just something off of AliExpress, no real name to it. My budget did not allow for genuine high-wind ball screws or anything like that, so I knew they were kind of janky. What I was also using is the stock pillow blocks that came with it, so the BK15 blocks that came with it, and I never really took a second look at them. They came with it, so why would I buy something else, since I didn't really know too much about it. But taking one apart, I quickly figured out that they are just using deep groove ball bearings and not actually angular contact bearings. Which, if you have a bunch of load on them, is not exactly ideal. Now, if you're not familiar with angular contact bearings, in regular bearing you have the inner surface, you have the outer surface, and then you have a ball in between that the whole thing rolls on. And usually, so that the whole thing doesn't fall apart, you have a bit of a groove that the ball runs in. Now, with a deep groove ball bearing, that groove just means that the groove is relatively deep, so that the ball is very well catched in there. But it is just symmetrical on both sides, and as long as you put lateral force on it, this works great and is rated for very high loads. However, if you put axial load on it, those bearings don't like that at all, and usually have quite a bit of slop in the axial direction. And the problem is that with a bearing block for a ball screw, you are putting both radial and axial load on it, and if you just have two deep groove ball bearings there, the axial load might have some play. Now, it's not horrible, and for most applications this might actually be fine, but in a CNC where you really want to minimize the backlash, having a tiny bit of play in there just meant that there was more play everywhere. Now, by the way that I measured that is, first I measured the whole backlash by just putting in dial test indicator on my cross-slide, going back and forth and kind of seeing how many steps of 10 micron do I need until the needle starts moving. It's not the most precise way of doing it, but it's the best way I have access to. Then instead of putting the test indicator on the cross slide, I actually put it on the nut that connects the ball screw with the motor, and there it's even more of a rough measurement, but I was seeing almost as much backlash on the nut itself, which meant that the whole ball screw was moving. And if you want to have it fixed, it moving better than that, not a great thing. So what I did is I went online and looked for some angular contact bearing blocks like these ones. Now, you can spend a lot of money on bearing blocks or very little money on bearing blocks. Sadly, I do not have a lot of money, so I went for the highest quality cheap one that I could find. These ones do have angular contact bearings. They have a rating of C5 that is on them. If they are actually C5, I have no way of verifying, but I'll inclined to believe them that they're probably better than my deep groove ball bearing, and they did not cost an arm and a leg. Just kind of feeling them, they are not perfectly even all around. What you often have with cheaper ball bearings is that they are just kind of slightly shift depending on which part of the rotation you're in. Now, there are ways to shim that out or to make sure you clock the bearings correctly. I'm not doing any of that. I don't really have any equipment to properly measure that or experience how to do that. So I just put them in like I got them, and that already improved backlash quite a bit. What also probably helped a bit is the nut that retains the ball screw inside of this block has a little set screw to make sure that it doesn't come loose. On the old ones, the set screw was just going directly on the thread. So depending on whether it was on a hill or a valley of the thread, it was probably not clamping on as well, and it might have let that nut come loose slightly. I have no way of measuring whether the nut came loose or not. It didn't feel loose, but that's a possibility. On the new nuts, it actually has a little brass piece that pushes down on the threads, and that is actually formed like the threads. So no matter where on the thread the nut currently is, it's going to clamp down the same, so that definitely also helps. I made sure to tighten down this nut as much as I could reasonably do without proper equipment to hold everything down. It's not clamped super tightly, but it's definitely also not loose by any means. And with that, I was able to get down the backlash from 100 micron to around 40 micron roughly. Once again, I don't have a great way of measuring it, but it's probably somewhere between 30 and 50 micron. That's about as accurate as I would classify that number. That is roughly 2 thou, maybe a bit less for your American friends. That already is a lot better, and considering that the ball screw itself is rated for almost that amount of axial slop, I was probably happy with that. Now on the load, these numbers might be slightly higher, but one other thing I wanted to try is I'm using double ball nuts on these ball screws. So what I did is I wanted to see how well are they preloaded. And taking off the little cover that holds everything in place, I noticed that the little brackets that are in between are quite loose. At least on the y-axis, they almost fell out. They were only basically held in place by grease. And if I just kind of manually tension to the two ball nuts against each other, just with my hands, that slot that holds them to each other was not quite aligned anymore, which basically means that there were not really much pre-tension at all. And it was probably just behaving like a single ball nut. I just paid the price for a double ball nut. Now what I did is I added some shims in there. I put a 40 micron shim in there, which if you ask me why 40 micron, it's the only shim I had. So I tried it and it works. It's probably on the thick side. If I had a 30 micron shim, that would probably have been better. But I put those in, and then I kind of tightened them against each other. I was able to just barely put the retention brackets back in, and I could feel that the knot now had slightly more resistance to turning on it, but I'm still able to move the ball knot with my bare hands, so it's not clamping down overly hard. So I think it should be fine. Let me know down in the comments if this is a big no-no and I'm gonna ruin my ball screws this way, but considering how much I paid for those, I think they're already ruined out of the factory. Now with that, my measuring of the backlash is not that accurate, so I got a roughly similar numbers, tending a bit lower, more like 30 to 40 micron. So I think that's about as good as I'm gonna get with my equipment. So I plugged in 30 micron and Mach 4's backlash compensation, reran my backlash tests, and as far as I can tell with my measurement tools, the backlash is now gone. Now, that's of course stuff for cheats, but I think that's reasonably speaking is about as good as I'm gonna get with just Gibbs and cheap ball screws. But now that we have tackled the y-axis, I probably already overlaid the footage for the x-axis, and let's move on to seeing how that went. Alright, so as you can see, everything is back together now. The X and Y axis are fully assembled. Now, turns out that on the X-axis, the ball knot was actually a lot better. It was roughly the same tightness as the Y-axis was after adding the shim. So that tells me two things. For one, the thickness of my shim was appropriate. It felt about the same afterwards. I was worried that my shim was a bit too thick and it was putting too much pressure on it, but the other one is the same, so that should be fine. And two, they're clearly not making these to any kind of specification, but just kind of milling them and throwing them together, hoping that the tolerances add up, as like the difference between the two was immense. That means for you, if you're getting some cheap ball screws with double locking nuts, make sure to check them if they need some shims or not. But everything put together now, the backlash on the x-axis is now about 15 micron, which is actually really good. It's kind of hard to measure as the movement is not all that smooth and everything, but it should be somewhere below 20 micron, so less than a thou, basically, and that is perfectly acceptable. That's like about half as much as on the y-axis. I have now put the indicator on the z-axis, and well, something is clearly loose there because I'm measuring like 0.6 millimeters, so 600 micron of backlash there. I have a feeling that something like one of the bolts came loose, and that's why it's flopping all over the place. But I will do the same treatment there, replace the bearing block, check the ball nuts, and see what else is loose in there. Oh, it looks like the grid mystery has been solved. Taking this apart and seeing what I had done as the solution to connect the C-axis lead screw with the main head. Well, I'm not sure what I was thinking that this was a good idea. As you can see, it was flopping back and forth. That clearly is where that backlash came from, and I'm surprised it didn't appear sooner. Now, the main question now is, what do we replace this with? Ideally, I would mill this out of an entire block, one piece, instead of having any sort of connecting mechanism. Second best would be to have just a better way of bolting it together. Milling it out of one piece would be easy enough on the CNC, on the BF30, but well, this is the part I need for this BF30. On the Killer Bee, that is a very tall piece, and well, even out of aluminum, that would be a tall order on the Killer Bee, just based on the tool stick out, and out of steel, while the Killer Bee can cut some steel, not this thick. But while I was deliberating, thinking how do I best do this, I thought, well, we have a certain sponsor, and apart from just cool swag, they also have manufacturing services such as CNC. So here we go. Big thank you to PCBWay for providing me with this part. I drew it up on the computer real quick. I knew it was going to be CNC machine, so I make sure to have everything very easily CNC machinable, and then put it in their online machining calculator, and was very much surprised by how affordable it is to get something like this custom machined. It's not an overly complicated part, but it needs the outline from here with a fairly precise bore. I did specify a specific tolerance for this bore, which is tighter than their default tolerance. 6 tapped holes here, and then it needs second operation to get these 2 holes here, and also chamfers all around. So not overly complicated part, but also not trivial. And all of this, including material, just $50. That's, I mean, if I drove out to my metal supplier, bought some stock material, probably bought way more than I needed because I cannot go there without buying too much, and buying some extra tooling, maybe I would have probably been almost in this deep, and well, still had the effort of making it. So definitely a great option for you guys if you need anything CNC machine for one of your machines. $50 for this piece, can't complain. Like buying something like this off the shelf could run $50 easily. So how about we put this together and see how it fits. Now, spoiler alert, I already did try the fit of this bore, and it fits beautifully. Their standard tolerance for, if you don't specify anything, is fairly loose. So if you have any critical parts, anything that needs fit with other parts, make sure to provide a technical drawing and put tighter tolerances, like just what you need, not too tight, but if they are reasonable, then it's not even going to cost you an extra. Like having a tighter tolerance on this bore did not cost me anything extra, or PCBWay paid for it anyhow, but it was not any more to the price, so that is quite good. Now, of course, if you look at the part in great detail, there are some scratches here. There are tooling marks here on the side. You can see that this end mill is a bit long in the tooth and might need replacing, but this part is going in the machine. Nobody's ever going to see it. And they also have surface treatment options like bead blasting and stuff like that. So if you really care about tooling marks, you can take one of those options. Well, I'm just really happy with how this fit on here. And let's bolt it in. Perfect fit. I love it when the holes just line up. I mean, I have no reason to believe they wouldn't, but that means that not only did they manufacture it correctly, I also measured the part correctly. On here, I've also already put the new bearing block with the angular contact bearings. And that should just slide on in. And then with the help of the new better lock nut, which in this case was actually loose, On the Z-axis it was not fully seated in. Now, in the interest of a satisfying video and also my own interest, I would love to tell you now that with everything installed, the backlash in Z is completely gone, or it's down to only like 10 or 20 micron. But, well, reality got in the way again. I mean, to be fair, the backlash is greatly improved. Instead of 50 times what I would call acceptable, it's now down to roughly 5 times. But it still is at 5 times what I would call acceptable, at around 0.1 millimeter backlash, possibly with slightly more, and that is still no fun. That's about 5 thou if my math is correct. I'd love to get it down to 1 thou or like 20 micron. I honestly don't know what it is, and this video has already dragged on for like multiple months to film. Forgot when I actually started it. I hope it was somewhat cohesive. It's been at least 2 months, probably more like 3 months. But it is back together, and the X and Y axis are greatly improved, and the Z axis is also greatly improved. But I will still have to do some further investigation, and there are also quite a few other things that I was meaning to do actually in this video to the machine, just like some general housekeeping items of like sprucing it up a bit, making it a bit more nice to use, like finally setting up the tool setter, stuff like that. But that's gonna have to wait for next video, and there I'll also update you on the backlash situation. But in the meantime, I hope you guys enjoyed this video, found something helpful, and if you have any suggestions of what I should try, leave them down in the comments. I'm very open to that, and kind of at a loss right now. I haven't gone through and measured every single joint, but I had it down to, I measured it when I built the machine first. It was down at 90 micron, so 0.09 millimeters. Which is less than it is now, and that was with the stupid block situation. So I'm really not sure what exactly is the problem here at the moment. To PCBWay for sponsoring this video and providing the metal piece for the Z-axis here. It was able to probably lead to a 10x decrease in backlash. Now, isn't that a headline? Now, never mind that before it was loosely pivoting on 2 screws, but 10x improvement. And with that said, thank you guys for watching. Make sure to like, comment, subscribe. Stay tuned for the next one, and I'll see you later.